Hey guys, it's Mrs. Kraus, and we left off our last video by talking about the steps of the chi-square test. So our chi-square test, again, is used to determine whether we should reject or fail to reject, which means support our null hypothesis. Our first step is to actually define our null hypothesis, and ours was that there's no statistically significant difference between the number of sodium ions entering the TTX nerve cells versus the normal nerve cells. Our second step of the chi-square test is to determine our expected values. Now, typically we need to find our expected decimal frequencies and then multiply by the total sample size to get whole numbers for our expected values. Okay. Now, for our experiment, it's actually quite simple. According to the null hypothesis, if there's no difference between the number of sodium ions entering the TTX nerve cells and the normal nerve cells, we can simply take the total number of sodium ions in the experiment, which is 366, and divide by 2 to get the number we expect on each side. So, what I did was I took 366 and divided by 2, and I ended up with 183 as my expected values for both TTX and normal nerve cells. Now, if we look back to the data table on the first page, remember when we summed up the values from all the trials, we had 35 sodium ions entering the TTX nerve cells and 331 sodium ions entering the normal nerve cells. Those are our observed values. Okay, so I filled in 35 for TTX and 331 for observed. And I'm sorry that this key is so hard to see. Okay. Once we know our expected and our observed values, our next step is to calculate our chi-square value. So we're going to use this equation. And in this equation, O stands for our observed values, and E stands for our expected values. Okay, then if we're doing this for our TTX versus our normal nerve cells, let me go back to my key. I'm filling in my values for O and E for the TTX and the normal nerve cells. So I've got 35 as my O for TTX, 331 as my O for normal, 183 for my E for both TTX and normal nerve cells. And then what I'm going to do according to my chi-square equation is I'm going to take O minus E, square that, and then divide it by E. So 35 minus 183 squared divided by 183 for the TTX nerve cells. And that gives me a value of 120. If I do the same for the normal nerve cells, I'll take 331, which is O, subtract 183, which is E, square that, and divide by 183. I get 120 again. Now, I did have something missing from the chi-square equation on your worksheet. It should say that chi-squared equals this epsilon symbol, which means the sum of O minus E squared over E. So what we're going to have to do is we're going to have to add our O minus E squared over E values for TTX nerve cells and our normal nerve cells together to get our final chi-square value. So that would be 120 plus 120 is 240. Our next step involves determining something called the critical value. To do that, we have to use a critical values chart. In order to use the critical values chart, we need to know the number of degrees of freedom for our data. Degrees of freedom is the number of data sets, which is n minus 1. In this case, we have two data sets, the TTX nerve cells and the normal nerve cells. So 2 minus 1 means we have 1 degree of freedom. So we're going to look in the 1 degree of freedom row, and we're going to look at a p-value of 0.05, because that's what scientists use typically. So we find where 1 degree of freedom intersects with p equals 0.05, and I get a chi-square value of a critical value of 3.84. So again, my critical value is 3.84. Our next step is to compare our chi-square value to our critical value so that we can draw a conclusion. If the chi-square value is higher than the critical value, we reject the null hypothesis. If our chi-square value is lower than the critical value, we support or fail to reject our null hypothesis. For our experiment, our chi-square value that we calculated was 240. Our critical value that we found on the critical values chart was 3.84. So our chi-square value of 240 is much higher than our critical value of 3.84. Therefore, we reject our null hypothesis. That means that there may be a statistically significant difference between the number of sodium ions entering the TTX nerve cells and the number of sodium ions entering the normal nerve cells. Okay, that's it. And that would bring you to the end of the worksheet, I believe. Yep. Okay, so again, we are rejecting our null hypothesis, which means we are failing to reject or supporting our alternate hypothesis. Okay, thank you.